Welcome everybody to Econ 143 midterm exam review session. In this particular review session, we are going to be talking about chapters 1 through 4, which is going to be on your midterm exam. So as far as studying for the test, here's how I'd go about it if I were you. I go through your class notes that hopefully you're taking while watching those videos. I've posted a study guide up there on iLearn for you, as well as this review session video and slides to help you organize your studying. You might want to go back through those thought-provoking assignments and homework problems to make sure you know how to answer similar questions that could appear on the exam. So I'm probably not going to ask you the exact same question, but I might ask you some questions that are similar. So again, if you can go back through and understand the answers to those questions, then you should probably be good to go for the test. And then please email me any questions you might have or join my Zoom office hours. I'm happy to answer any questions that you might have about the exam or the course or anything else for that matter. So with that in mind, let's go ahead and get into it. So the first thing that we talked about in Chapter 1 was the definition for environmental economics. And that is the application of the principles of economics to the study of how environmental resources are managed. Remember, economics is the idea that because of scarcity, we can't have everything we want. So you got to make choices in an effort to get the most we can out of those scarce resources. In economics, one of the first rules says that people respond to incentives, which are changes in costs and benefits. If the benefit of an option goes up, people will be more likely to choose it. If the cost of an action goes up, people might be less likely to choose it. And people generally respond in a predictable way. Right, so with that in mind, understand how people have harnessed incentives in the past in order to hopefully help the environment, as in the Worcester's pay-as-you-throw trash collection system, which says instead of paying a flat rate regardless of how much trash you throw away, you actually have to pay on a per unit basis. So you have to pay a certain dollar amount for every trash bag you throw away, and that encourages people to throw away a lot less trash. And those people have below average rates of trash disposal compared to the rest of the country. They throw away less trash on average than everybody else. And at the same time, they had an increase in recycling rates, right? So that policy seemed to have some pretty good effects. Now, it did have some unintended consequences, one of which is it may have resulted in more illegal dumping, so people just throwing their trash out in a way that couldn't be monitored. And also, it's kind of difficult to know how that policy or to have that policy work effectively in an apartment complex where people use the same dumpster to throw away trash there. So whenever you have that communal dumping area, it can be hard to enforce such a policy. We also talked about California's plastic bag ban, which says that you are no longer allowed to get those disposable plastic bags in the grocery store. You have to get those reusable bags and pay 10 cents a bag for them. Remember, that's done a pretty significant job of reducing the plastic bags that end up in the beaches and oceans. Right. Again, it's been estimated that you might have about 38 million less plastic bags being produced as a result of this plastic bag ban. Right. But also it has increased the amount of garbage bags that people are buying because they used to use those reusable plastic bags as garbage bags, and they're not really doing that as much anymore. Right. So again, it has some side effects or some secondary effects, which is the next thing that we talked about in class, is that idea of perverse incentives and secondary effects, and how those can cause environmental policies to backfire. So we talked about the example of an Endangered Species Act designed to protect the red-cockaded woodpecker. Remember, that was a woodpecker that was kind of on the endangered species list or going extinct down in Florida. So they passed a policy that says that if you have any woodpeckers nesting in these certain types of trees that they like to nest in on your property, you're not allowed to build within, say, 50 feet of that tree. As a result, people went down there and bought a bunch of land that had these trees on them, but at this point in time, no woodpeckers nesting in them. The first thing they did was cut down those trees before a woodpecker could nest in there and, again, remove their ability to use that property as they see fit. Right. So as a result, the natural habitat of the woodpecker became got devastated, and the woodpecker itself became far more endangered or less prevalent. So again, a policy that was designed to increase woodpecker populations actually reduced them. Right. The New Delhi cobra bounty is the exact opposite. This was a policy designed to reduce cobra populations, but actually increased it. Remember, the idea here was that the local government was going to pay everybody a certain amount for every cobra head they turned in. right? So the idea is that people on their way to work or school, if they spotted cobras, cut off their heads, turn them in, and get the bounty. But people were making so much money off this cobra bounty that they wanted to continue to make money off of it. So when the cobra population started to get sparse, they would start breeding cobras in their homes so they could keep cutting off the heads and turning it in to collect the bounty. Now, when the local government didn't see any more cobras running around on the streets, they got rid of the cobra bounties, so we're no longer going to pay you for these cobra heads. And so now people have these boxes of cobras in their homes that they no longer have a use for, so they just dumped them out into the streets. And there's actually more cobras running around the streets than before this policy was enacted. Then we talked about the Clean Air Act. Again, this said that if you are a new company or new industry that just got created and you just built your factory recently, you'd be subject to these Clean Air Act restrictions. However, if you're an old company, because it's more expensive for you to retrofit an old company and make it more environmentally friendly, then you would be exempt from these Clean Air Act regulations or restrictions. As a result, people stopped building the new buildings new factories that they were planning on building, because they knew if they did, then they'd be subject to more harsher regulations or more stricter controls. So this kept the older, more pollution-causing buildings longer than they otherwise would have. Or they delayed making any repairs to their building that would cause them to come under this new Clean Air Act. And as a result, this might have increased pollution rather than reduce it. So again, even though people do respond to incentives in a predictable way, sometimes policymakers don't understand or predict the way that people will respond to those incentives. For example, it should have been predicted that, again, we might cut down these trees that the woodpeckers like to nest in, or that we might start raising cobras in response to this bounty if you thought about it hard enough. But again, a lot of times policymakers, they don't think past those immediate effects to those secondary effects or perverse incentives that could cause environmental policy to backfire. So people kind of ask me, like, what's the difference between a perverse incentive and secondary effect? Well, a perverse incentive is an incentive that you've created in somebody that is in the opposite intention of what you hoped it would be. And as a result of that perverse incentive, you're going to get these secondary effects, right? So there really isn't a big difference between them, except that perverse incentives lead to secondary effects. You can think of kind of one as the impetus to the other. Also in Chapter 1, make sure you know the difference between positive economics and normative economics. Remember, a positive statement is testable, whereas a normative statement is not, because it's based on a subjective value judgment. Right? So for example, when you're talking to somebody, you could say it's 88 degrees outside. That's a positive statement. We can test that to see if it's true. Now that statement could be true or false, but again, the idea is that we can test it to see if it's true or false. Now if you're talking to somebody and you say it's too hot outside, well, that's more of a normative statement, right? Because what's too hot for one person might not be too hot for somebody else. So that's based on your subjective value judgment or opinion, and therefore isn't really testable, right? So again, make sure you understand the difference between positive and normative economics, right? Again, a positive economic statement might be something like, since 1900, the Earth's atmosphere has increased 1.4 degrees. Again, that could be true or false, but we can test that to see if it's true or false. A normative economic statement might be something along the lines like, since 1900, the Earth's atmospheric temperatures have increased too much, and we need to take steps to reduce this global warming. Well, again, that's not really something you can test as much as it's something that you believe, and therefore is a normative statement. Continuing on from that, make sure you understand the difference between the moral approach and economic approach to studying environmental economics. Remember, the moral approach is kind of the thing that's been indoctrinated into a lot of environmentalists over the years, and that is that the environment has this moral high ground. So you're making choice between environmental quality and, say, economic progress. If you take the environmental quality route, then you are morally superior to anybody who takes the economic progress route, right? So again, protecting the environment is good, not protecting the environment is evil. The economic approach, which is what we're going to be using most in this economics class, is the idea that there are competing preferences between, say, a cleaner environment and economic progress, and no one preference is considered right or wrong or more morally superior to the other, right? So again, people have different subjective preferences. Sometimes, it depends on the costs and benefits as to what you might prefer. And again, your preference isn't necessarily right or wrong from a moral standpoint, right? Again, it's just a matter of looking at the changes in costs and benefits and trying to find out the optimal solution. So with that in mind, please make sure you know the truths and fictions regarding climate change debate, right? So understand what the hardcore conservatives or I guess Republican Party might believe versus the hardcore liberals or maybe Democratic Party in terms of what they might believe, right? Remember, conservatives often have the belief that this climate change thing is a hoax and isn't really happening, or if it is happening, there's no scientific consensus that's being caused by humans, right? Whereas liberals believe not only is climate change a proven scientific fact, but there's universal scientific consensus that human beings are primarily the cause of this climate change that is occurring. In reality, it's again a little bit in between, right? There is pretty considerable evidence that the Earth has been warming, right, over the past 120 years or so. Having said that, there's also been time periods over the last 2,000 years where it has warmed with far less human behavior that might cause global warming. So it could be a natural result of the Earth's normal fluctuations in its temperature. Also, as far as there being universal scientific consensus, there are certainly some scientists who believe that human beings are primarily the cause of climate change. There are also some scientists out there who believe that human beings are not the primary cause of climate change, right? That debate is still pretty much open. I think a lot of scientists are kind of in the realm of believing that human beings certainly could be a contributing factor, if not necessarily the primary cause, right? But again, there's a lot of scientists on both sides of that debate. How much of the climate change is caused by human activity is one of three questions that economists really care about when studying climate change in this debate. So make sure you know these three questions. So again, when it comes to how economists view this debate, they're going to look at one, how much of the climate change is caused by human activity; two, what is the cost of reducing this human activity in an effort to slow down climate change; and three, what are the benefits of reducing human beings' contributions to climate change, and do those benefits outweigh the costs, right? So again, what are the costs, what are the benefits, and do the benefits outweigh the costs are kind of what the economists are concerned about when it comes to this debate, without focusing on those extremes or hyperbolic statements that people tend to make when it comes to this debate. Finally, be familiar with the main idea of the Green Deal, the Green New Deal. Remember, that main idea is that we are going to try to go to 100% completely clean and renewable energy sources, originally by the year 2030, although now critics are saying that at best maybe by the year 2050. But again, the main thing I want you to know is that the main idea behind this Green New Deal is that 100% of our energy sources are clean and renewable. Now, again, there's a whole bunch of other stuff on that Green New Deal. I'm not going to ask you to list any of that out, but do know what its major criticisms are. One of which is that there is a whole bunch of other stuff on this Green New Deal that has nothing to do with the environment. So it certainly looks like a certain political party is trying to push their agenda under the name or guise of helping the environment, which this Green New Deal could certainly do, right? But it does all this other extra stuff too that has little or nothing to do with the environment. Another major criticism is that the bill itself is incredibly vague. It says what it wants to do. It kind of gives you a wish list of where we hope society would be, but it doesn't really tell you, say any specifics about how we're going to get there or how we're going to accomplish some of these vague agendas. And then the final criticism is that this Green New Deal is incredibly expensive. Remember, we talked about it being between maybe $51 and $93 trillion. The reason why that range is so big is because the bill itself is so vague, it's hard to estimate exactly how much it would cost. But even at its minimum cost of $51 trillion, right, you're looking at a considerably expensive bill, which might be tough to pass at a time when our country is already over $24 trillion in debt. All right, so that's kind of what we talked about with Chapter 1. Again, not a lot of math or graphs in that particular chapter, right, mostly focused on terms and definitions and debates and ideas. Chapter 2 is similar, right? Know the following difference between these particular definitions and be able to give an example of each, right? So we talked about renewable resources. Those are resources that are going to replenish within our limited human time frame, and that could include things like timber stands. If you cut down trees, those trees can regrow, or fisheries. If you take fish out of the fishery or out of your or out of the ocean, those fish could replenish so long as you leave enough left to do so. Right? And we compare that to those non-renewable resources, and those are resources that do not replenish, at least not within the time frame that human beings would call renewable. Right? For example, a petroleum reservoir or a natural gas deposit, when you start using those, they might replenish over the course of millions of years, but again, not in a time frame quick enough for us to reuse within our lifespan. Right? So those are examples of some non-renewable resources. Now remember, just because a resource is non-renewable doesn't mean that we are running out very quickly, right? We talked briefly about this idea that we're not really going to be running out of oil anytime soon, right? Even though it is a non-renewable resource, just because there's so much vast oil deposits located throughout the world, as long as we're willing to go to greater lengths to get that oil, then we still got plenty of oil well into the future. And even as we go hundreds of years into the future, if we were to start to run out, oil becomes so expensive that we probably would have switched to a different energy resource before we actually ever ran out of it. Make sure you know the difference between non-cumulative and cumulative pollutants. Right? Remember that a non-cumulative pollutant is something like noise pollution. Right? It's a pollutant that would exist as long as the cause of the pollution is in effect. But as soon as you turn off the cause of this pollution, then that pollution goes away. It doesn't accumulate in the atmosphere and stay in the atmosphere long after the cause of the pollution has been eliminated. Whereas a cumulative pollutant is a pollutant like radioactive waste, where once it's produced, it's going to stay around, right? Even if you turn the source off, whatever pollution was produced before is still going to be there, and it will continue to accumulate in the environment as we produce more and more of it. Remember, the Earth has a certain assimilative capacity, or a certain amount of pollution that it can handle before suffering any negative effects. And with that in mind, something like human waste, right, is a non-cumulative pollutant so long as that amount of human waste is below the Earth's assimilative capacity, because there are things like microbes in that river or water that will dissolve and break down that human waste. But if that human waste is, if the amount of that human waste is greater than the Earth's assimilative capacity, then it becomes a cumulative pollutant, and that it will continue to exist even after the source of that pollution is turned off, and again continue to build up in the environment if it overwhelms that Earth's assimilative capacity. Speaking of assimilative capacity, make sure you understand the definition of what makes something sustainable, and that is when our current actions do not reduce our future opportunities. Or again, if you're looking at a production possibilities curve that explains how much we can produce as an economy, right? It's that production possibilities curve either staying where it is or shifting outward, basically just not shifting inward. And that's because we usually, and that would exist usually if we operate again below the Earth's assimilative capacity, where the amount of pollution we're producing doesn't have any negative effects on the environment. Also, make sure you understand the difference between a point source and a non-point source pollutant. Point source pollutants might be something like smokestacks, where you can see where the pollution is coming from. You can trace the pollution back to the source. A non-point source pollutant might be something like agricultural chemical runoff from a group of farmers, right? You'll know exactly who produced each exact amount of that agricultural runoff, right? You might have a hard time tracing that pollution back to its source. Right. Now remember that point source pollutants are usually easier to regulate because you can find out who's doing the polluting, whereas non-point source pollutants might be more difficult to regulate because you don't know necessarily who to charge or give a citation to as a result of it being vague where that pollution came from. And then finally, make sure you know the difference between continuous emissions and episodic emissions. A continuous emission is an emission that is going to occur as a natural part of our production process. For example, when we drive cars around, we emit carbon dioxide into the atmosphere, or again, a waste treatment plant as we continue to flush our toilets and send human waste into that waste treatment plant, right? These emissions are going to happen day after day, continuously, right, throughout time. Whereas an episodic emission is usually the result of kind of a freak accident. It's not something that normally occurs, but occurs if a mistake is made or somebody doesn't do their job well enough to contain whatever type of pollution they're supposed to contain, and it results in maybe something like an oil or chemical spill. So the question for the government when it comes to how to regulate these things is when it comes to continuous emissions, we got to decide how much should we allow, right, we might want to put in certain limits on how much is allowed to exist. Whereas with an episodic emission, the question for the government in terms of how to regulate it is what policy should be put in place to prevent it, and what policy should be put in place to ensure the quickest and most efficient cleanup of these types of activities. Right, so again, different regulatory questions for the government depending on whether it is a continuous emission or an episodic emission. And I believe that is it for chapter 2, other than, again, making sure you understand the idea of sustainability and how that was demonstrated on the production possibilities curve, which I mentioned in the last slide. Right, remember that to be considered sustainable, that production possibilities curve can't be shifting inward. It has to either stay where it is or shift outward. And again, know that definition for assimilative capacity. That's a certain amount of a pollutant that the system can handle without suffering any adverse effects. And know that's important for determining environmental policy, right? We talked about how, again, we might not want to get rid of all of the pollution that is out there. We might not necessarily want to go through the extreme expense of making sure 100% of our energy sources are coming from clean and renewable sources if, again, there's a certain amount of pollution that the earth can handle, right, without suffering those adverse effects. Again, anything worth doing is worth doing imperfectly, according to the economist. Sometimes perfection isn't worth achieving. In fact, almost all the time, perfection isn't worth achieving, just because the costs of perfection usually outweigh the benefits of perfection. And that is certainly true when it comes to protecting the environment if there is a certain amount of pollution that our system can handle without suffering those adverse effects. All right, so let's move on into chapter 3. Make sure you know what a demand curve looks like. It's that downward sloping curve, and be able to derive that from people's marginal willingness to pay. Right? Remember that the more you have of something, the less you're usually willing to pay for it. The less of something you have, usually the more you're willing to pay for it. So that marginal willingness to pay tends to go down as you increase the quantity of a good that you have, and that's what results in that downward sloping demand curve. Right? Now, to derive a supply curve from that concept of marginal cost. Remember that marginal cost tends to increase as a result of that law of diminishing marginal returns, which says as you add more and more variable units to a fixed set of resources, right, they're going to start to crowd each other out. It's become more expensive to produce stuff. Also, make sure you understand how to use that equal marginal principle, which says that you are going to use sources from wherever it is cheapest until it is equally expensive no matter where you use that source from. We did an example of that in class. We also did one as part of your thought-provoking activities for that week. So again, make sure you check that out there in week 3 if you have questions about how to do that. With that in mind, I do have an example right here that we can go through. So it says, assume that you want to produce 6 kilowatts of energy. How much do you save in cost using the equal marginal principle compared to splitting production equally between coal and nuclear energy? Right, so first of all, again, when you're using the equal marginal principle, you want to take it from the cheapest source. So we got 2 sources here. We got coal power and nuclear power. If you take it, the energy source from coal, for the first unit, it's going to cost you $100. If you take it from nuclear for the first unit, it's going to cost you $150. Again, you're going to take it from wherever it is cheapest. And so with that in mind, right, we're going to take our first energy source here from coal. Why is our first one coming from coal? Well, because 100 is less than 150, so that's where it's cheapest to use that energy from. Now, when it comes to the second energy source, we need to compare our second, the cost of our taking a second unit from coal versus the cost of taking a first unit from nuclear. And in this case, it is the same, so you could really go in either direction here. But let's go ahead and stay with coal and say that we're going to take our second source from here, right? So when it comes to taking our third source, we can either take a third source from coal or a first source from nuclear. If we take it from coal, it's going to cost $200. If we take it from nuclear, it's only going to cost $150. So now, for the first time, it is definitely cheaper to use nuclear power than it is to use coal. So our third energy source should come from nuclear, right? Now, again, we need a total of 6, so if we're going to pick our fourth energy source, again, if it comes from our third unit of coal, it's going to cost $200. If it comes from our second unit of nuclear, it's going to cost $300. It is cheaper to use coal than the nuclear here, So our fourth source is going to come from here, right? Now, when it comes to our fifth source, right, our fifth source can come from coal or, come from our fourth unit of coal or second unit of nuclear. Again, coal is cheaper than nuclear, so let's go ahead and say this source here comes from coal, right, 250 being less than 300. And then our sixth and final source of energy, where should that come from? Well, again, it can come from our second unit of nuclear or our fifth unit of coal, right? Either way, it's going to cost the same. That's how we know we kind of minimized our costs. With that in mind, for the sake of argument, we'll just say it's nuclear, although, again, it really wouldn't matter if you said it came from coal, right? So now you have your six sources coming from the cheapest places possible, right? Again, if we wanted to use this equal marginal principle to calculate our total expense, then we just got to add up these costs. So we got 100 plus the 150 plus the 200 plus the 250. Again, I'm just adding up the total cost from coal by using those four sources of coal that we talked about. And then we add into that the cost of the two sources from nuclear. So that's going to be 150 and 300. So again, where these numbers come from is I'm just using all these sources here that we agreed to use in this equal marginal principle. If you add up those numbers, then you should get 1,150 as the total amount from the equal marginal principle. Now it says, how do you compare that to when you split production equally between coal and nuclear energy? Right, well, if we wanted to split production evenly, which I'm just going to do over here on the side, then that means that you're going to have 3 from coal and you're going to have 3 from nuclear. Right, so you just take the first 3 units of coal there, 100, 150, and 200. And then the first 3 sources of nuclear, that looks like 150, 300, and 450. And then you just add those up, right? So we got a total of 450 coming from coal. We got a total of 900 coming from nuclear. Add those up and you get 1,350. So how much do you save by using the equal marginal principle compared to splitting them evenly? With the equal marginal principle, it's 1,150, right? With the split evenly, it's 1,350. So you would save, in this case, $200. So I was getting sloppy there, right? By using the equal marginal principle. Right now, again, that's one way that you can do it. Now, another way that you can do it is that the difference between splitting them evenly versus the equal marginal principle is that if you split them evenly, you wouldn't use the fourth source of coal there. You'd be using the third source of nuclear instead. And if you look at the difference between those two, it's that same $200 difference. All right, so you can also look at it that way if it worked out that way on the exam. Although I think adding up the equal marginal principle costs versus the split evenly costs might be the safest way to do it. All right. But in any case, that's how you'd answer that particular question. Should you see it on the test? And you certainly might. Also in Chapter 3, make sure you know all the characteristics of a market equilibrium. Remember that all trades generating more benefits than costs are undertaken. No trades generating more costs than benefits are undertaken. So again, when we're in market equilibrium, all the transactions that are happening are transactions where the benefit to the buyer are outweighing the cost to the seller. No trades generating more costs than benefits are undertaken means that there are no transactions where the cost to the seller outweigh the benefits to the buyer. And of course, this is all true assuming that there's no externalities in the market, which is what we're going to talk about in Chapter 4. Also, the combined area of that producer and consumer surplus, called total welfare, is maximized or as big as it can possibly be when we are in market equilibrium. and there's no excess supply or excess demand. So there's no situations where quantity supplied is greater than quantity demanded. Right? Remember, if that did exist in a free and unregulated market, there'd be a tendency for price to go down, causing people to produce less and people to buy more until you're in equilibrium. There's also no excess demand, or a situation where quantity demand is greater than quantity supplied, also known as a shortage. If that were to happen, there'd be a tendency for that price to rise in a free and unregulated market, causing people to want to buy less at a time that people want to produce more, right, until that shortage is eliminated. And again, the quantity demanded is equal to quantity supplied. So be able to solve for and graphically represent a market equilibrium from a set of equations. So again, this is an example that we've done several times in class, but make sure you can do it on the exam. Right. So for example, if I give you a question like this, the market for plastics is represented by a demand curve that is P equals to 110 minus Q, and the supply curve is equal to 10 plus Q. Again, even if I don't tell you that those are the demand and supply curves, you should be able to recognize them. Remember that the demand curve has an inverse relationship between price and quantity, whereas the supply curve has a positive relationship between inverse and quantity. Right? Remember that those demand curves are downward sloping, indicating that negative relationship. Supply curves are upward sloping, indicating that positive relationship. So remember, the rules here is that you set the two equations equal to each other to find Q star. You can plug that Q star into either or both equations to determine your P star. And then you set Q equal to 0 to find the demand and supply intercepts. So you should be able to do that so that you can draw out the graph and then calculate things like consumer surplus as the area under the demand curve but above the equilibrium price that you calculated. Remember, that's that formula, that area of a triangle, 1/2 base times height. You need to be able to calculate producer surplus as the area above the supply curve but below price, or that P star you calculated. Again, that's the same area of a triangle formula, 1/2 base times height. And then, of course, you can calculate total welfare by adding consumer surplus and producer surplus together. All right, so with that in mind, let's make sure that we can do a question like that on the test. So here's an example, right? Again, using those same two equations, let's go ahead and graph this out. So again, I'm going to exit my full screen mode here so we can start using our different colors. And let's go ahead and start drawing this graph. Maybe we got a graph that looks something like this. Again, we got price and quantity, right? So we're going to have a downward sloping demand curve. We need to figure out where that demand curve is going to start on that graph. Again, we do that by setting Q equal to 0. If we do that, then we can see that price is equal to 110, right? So again, we're going to have a demand curve, look something like this. We got 110 here. We also find out where it hits the x-axis by setting P equal to 0. And once again, our Q is going to equal 110. So that's where we're going to hit this x-axis here, right? Now we also have a supply curve that's upward sloping. In order to figure out where that supply curve is going to originate on that y-axis, again, we need to set Q equal to 0. Again, you're going to see that our price here is going to start off here at 10. And if you're trying to draw this to scale, it's going to have the same slope because they have the same magnitude of 1. All right. So we're starting off here at 10. We have that upward sloping supply curve. Now, where those two curves intersect, that's going to give you your equilibrium price and quantity. Right. Now, if this is a market without an externality, we call it Q star. If there's a market that has the potential for an externality, we would call it QM for just our market equilibrium. Let's go ahead and call it that for now, in case we decide we want to throw an externality into this market later. Just call it QM and PM. Right. All right, now the first thing that we need to do is we need to figure out what this market equilibrium is. So let's go ahead and do that by setting these two equations equal to each other. right? So again, we're just going to put or set our supply equal to demand. So in this case, that's going to be 10 plus Q is going to equal 110 minus Q. Right, now we need to get our Q's to the same side, so we're going to add this Q on the right over to the left, so that's going to be 2Q. And then we'll subtract that 10 over from both sides. So move that 10, that negative 10 over to the other side here, and so that 2Q is going to equal 100. And so we know that our QM here is going to be equal to 50. So 50 is QM. Right, now, in order to figure out that equilibrium price, we just got to plug that 50 into either of these two equations. Right, so in other words, we can plug it into the demand equation. So PM is equal to 110 minus 50. Or we can plug it into our supply equation. So PM is equal to 10 plus 50. Right, either way, again, you should get the same answer. In this case, that answer is 60. All right, so 60 is our equilibrium price. Now from here we can figure out our consumer surplus and our producer surplus. Right. So we'll do the consumer surplus in blue here. Remember, that is the area below the demand curve. But above price. Right. If we want to calculate consumer surplus, which is just the area of this triangle here, again, that is 1/2 base times height. Right. So that's equal to 1/2 the base of that triangle, and the base of that triangle is just the number of transactions when we're in market equilibrium, or 50. Right. So again, if you're looking at the base of this triangle here, that's where that comes from. And then the height of this triangle is the difference between 110, or that demand choke price, where when we set Q equal to 0, right, that's where we originated on that y-axis for our demand curve. And again, it's the difference between that and our equilibrium price of 60. So again, that's 50. Right. So for our consumer surplus, it is 1/2 of 50 times 50, or 1/2 of 2,500, which is 1,250. Right. Now, if we wanted to calculate out our producer surplus, we could certainly do that. Remember, that is the area above the supply curve, but below price. So you're looking at this area here for producer surplus. Right. So again, it's got the same formula. Still the area of a triangle, 1/2 base times height. Again, the base of that triangle is that same 50, which is the number of transactions. And then the height of that triangle, again, is the difference between the equilibrium price of 60 and that supply choke price where we set Q equal to 0, and that supply curve originated at 10. So again, 50 is what we're looking at here. So again, it's 1/2 of 2,500, or 1,250 as our producer surplus. Now, they certainly don't always have to be equal. In fact, they usually aren't, right? But in this case, right, it turned out to be the case. Now, with that in mind, we can add our consumer surplus and our producer surplus together and get what we call total welfare. Right, so again, if we add the consumer and producer surplus together, we get a total welfare of 2,500. And again, that's going to be as big as it can possibly be in market equilibrium, right? That number won't get any bigger in this particular market. All right, so that's everything that we just talked about in the last slide. So again, if you go back to that last slide, what I said you had to do here for this part in chapter 3 is, again, be able to set the two equations equal to each other to find Q star, plug Q star into either or both equations and determine P star. Make sure you set Q equal to 0 to find the demand and supply intercepts, so you can calculate consumer surplus, producer surplus, add those together to get total welfare, right? So we did all that in this graph, so if you can do that, you should be okay with that much on this part of the exam. Right, now we're going to come back to this graph later when we start talking about externalities and take a look at how that affects this particular market. But also in Chapter 3, make sure you know the characteristics of a perfectly competitive market. Remember that occurs where you have a large number of firms and consumers in the market, so no one producer or consumer can change the price. So these perfectly competitive markets are often called price takers, right? Because again, you have to take whatever the market price is, right? These producers don't get to choose the price. And the reason why these producers don't get to choose the price is because all the products that they produce are identical to all the other producers' products. Right? So again, if you're a wheat farmer, the wheat that you're making is the exact same as the other farmer's wheat. There's really no difference between them. Or if you're an orange grower, the oranges you're growing are the exact same as the other farmer's oranges. Right? Again, there's not really a big difference between them. Right? So with that in mind, again, all of these products are identical. So if the market price for, say, a bag of oranges is $5, right, then every orange producer out there gets to sell their oranges for $5, right? If they try to sell them for a penny more, nobody would buy them because everybody else is producing the same oranges for $5. If they sell them for a penny less, right, they could do that, but there's no reason to sell it for a penny less because they can sell all the oranges that they want at that market price. So they just be costing themselves money if they try to drop their price. Right? Also, there are no barriers to entry or exit in these perfectly competitive markets. It's easy and free to jump in and out of these markets as you please. There are low costs to obtaining information, engaging in transactions in this market. Right? So again, there's no barriers to keeping you from engaging in trade. And then again, firms can sell all they want at the market price. So please understand how firms maximize profits by producing where marginal revenue is equal to marginal cost. So know that profit maximizing rule and be able to calculate the profits that a firm is making. So with that in mind, all right, if we're staying in the same plastic market from the previous example, if the total cost in this particular market is given by this equation, Q star plus 50Q plus 25, and the marginal cost is 2Q plus 50, and then the average total cost is Q plus 50 plus 25 divided by Q. Using those equations, be able to tell me what the optimal amount of production for each of these firms in the plastic industry is, and also tell me how much profit that the firm is making. Is this plastic market in a long-run equilibrium? Explain why or why not. So these are the kinds of things that you might have to do for this particular type of question. Now, on the exam, I might just give you total cost as Q squared plus 50Q plus 25. And from that, you can certainly find out what marginal cost is, right? Remember, you just take the derivative of total cost with respect to Q, right? If you do that, that's where you get the 2Q plus 50. And you certainly should be able to figure out what the average total cost equation is. That's just total cost divided by quantity, or that total cost equation, if you divided each of those terms by Q, is how you get the Q plus 50 plus 25 divided by Q. Right. So the rules for solving this set of or this kind of problem is to set marginal cost equal to marginal revenue and then solve for Q star. And then use that Q star to determine the firm's profits. In other words, plug Q star into your total revenue and total cost equation. Right. Remember that total revenue, that profit. I can get my pen to work here. There we go. So profit is equal to total revenue minus total cost, where total revenue is given by that formula P times that Q that you're producing, right? So you take your price and you multiply it by that Q star that you just calculated in item 1 there of these directions. And then total cost is that total cost equation that is given to you, right? That Q star plus 50Q plus 25, again with your Q star plugged into that equation, right? And then from there you can determine if the market is in long-run equilibrium, and the way you figure that out is if it has zero economic profit, then it is in long-run equilibrium. If it has a positive economic profit, then it is not in long-run equilibrium, and you can expect firms to jump in and enter into this market, compete away those positive economic profits. If it is making a negative profit, or what we call an economic loss, it is also not in long-run equilibrium, and you can expect firms to leave the market until the remaining firms are making that zero economic profit. So with that in mind, let's go ahead and go through how to solve this one. So again, we're going to exit the full screen so we can use our different colors. So with that in mind, remember that the first rule here is that you need to find the profit maximizing quantity. In order to do that, you need to set our marginal cost equal to marginal revenue. But if the marginal revenue is greater than the marginal cost when it comes to producing an item, firms are going to want to make more of it. If the marginal cost is greater than the marginal revenue when it comes to producing an item, then firms are going to want to make less of it until, again, they get to this point where MC equals MR. Right? So, again, we're going to use our MC equation, which is 2Q plus 50, as given to you in the problem. And then as far as figuring out what marginal revenue is, again, going back to the last slide, remember that for a price taker firm, marginal revenue is going to be equal to the price, right? So if you go back to our characteristics of a price taker market, right, because these firms can sell all they want at the market price and don't have to lower the price, marginal revenue is going to be equal to price for that particular firm, right? So we just need to know what price this firm is going to be charging, and with that in mind, we know what their marginal revenue is. And again, they have to take the market price, so whatever we calculated out as our equilibrium price, that's the market price that all these price taker markets have to charge. So in that last problem, we calculated that out as 60, right? So that's going to be the equilibrium price and the marginal revenue for this firm, and so that's what we're going to plug into this equation here. Right? So again, it's 2Q plus 50 is equal to 60. Right? So now we've got 2Q is going to be equal to 10. So our Q star is going to be equal to 5. So the profit maximizing quantity for each of the firms in this particular market is 5 units. Now, if we want to figure out profit, if I can get this pen to work. I don't know if it's running short on batteries or what, but it seems to be struggling here. There we go. So our profit is equal to total revenue minus total cost. Right, and again, we're going to use this formula where we're going to plug in our Q star for each of these equations. So remember, our total revenue is that price. That's actually supposed to be a P there. Let's redo that. So we equal to price times quantity, and then our total cost equation is that Q star plus 50Q plus 25. All right, again, and we're going to do this at that Q star where Q star is equal to 5 units. All right, so let's go ahead and do this. So we got a price of 60 times a quantity of 5 minus, and now we're going to plug that 5 into our total cost equation. So that's 5 squared plus 50 times 5 plus 25. All right, so this is going to be equal to 300 minus, that's 25 plus, oh, let me do that. That's 25 plus 250 plus 25, which is also 300. Is going to be equal to 0. Right, so the economic profit here is 0. And with that in mind, we know that this firm is in long run equilibrium. Again, if this was a positive number, right, if our economic profit is greater than 0, then firms are going to enter and drive prices and profits down until they're 0. If it's less than 0, those firms are going to leave until the remaining firms are making 0 economic profit. And if it's equal to 0, then that's how we know we are in that long run equilibrium. So in this case, we know that we are in long run equilibrium. Now, another way that you can figure out a profit, if you prefer, is that profit is also equal to price minus average total cost times Q star. That's essentially your profit per unit times the number of units. And again, this is going to be at Q star is equal to 5, right? So again, we know that we have a price of 60 minus, and then we can plug that 5 into our average total cost equation. So that's 5 plus 50 plus 25 over 5. Again, we multiply this whole thing by 5, right? So again, that's 60 minus 60, which is 0, times 5, which is equal to 0. So you can calculate profit in that way as well, if you're wondering where you might use that average total cost equation. Right, so again, you can calculate either way, total revenue minus total cost, or price minus average total cost times Q star. Either way, you should get the same number there. All right, now, a couple things to note. So again, where did we get that marginal revenue? Remember that marginal revenue is equal to price, which we actually calculated back here in our last problem as 60. Now notice that this market is producing a total of 50 units. So we have 50 units being produced in this particular market. And each representative firm here looks like they are producing 5 units. So if I were to ask you on the exam how many firms are in this market, you should be able to tell me that there are 10 firms. Why? Because the profit maximizing quantity for each firm is 5 units, and there's a total of 50 units being produced, right? That's the quantity that's being produced in the market by all these firms together, right? So again, if each firm is producing 5 units and the total amount being produced is 50 units, 50 divided by 5 is 10. There are 10 firms in this industry. So to be able to answer a question like that, if I were to give you that question on the exam. All right. So with that in mind, let's go ahead and keep on rolling. That's it as far as the math stuff is concerned for Chapter 3. So let's go ahead and move on into Chapter 4. Make sure you understand what an externality is and know the difference between negative and positive externalities, as well as what problems those pose for the market. Be able to give an example of each. So in the case of a negative externality, that's where, again, the producer gets both the costs and the benefits. Right? If the benefits outweigh the costs, they're going to do it. And the problem is that all these activities are going to create external costs for everybody else. So everybody else doesn't get the benefits, they just get the costs. So external costs are created, and as a result, the market will produce too much of this stuff, or more than we'd like the market to produce. Right? So again, examples of this could include things like pollution or secondhand smoke. Right? Again, byproducts of production that tend to have negative effects on non-consenting third parties who had no say in whether or not this should be made. A positive externality is where external benefits are created. So again, the producer gets both the costs and the benefits, and if the costs outweigh the benefit, they're not going to do this thing. And that's problematic for everybody else, right? Because everybody else only gets the benefits, so they want you to do this thing more than you want to do it, right? So example of this would be like flu vaccinations. Again, when you get vaccinated from the flu, you pay all the costs. You do get the benefits of a lower chance of getting the flu that year. Everybody else, they just get the benefits of being less likely to catch the flu from you, right? So again, because of this situation, there's going to be too little of this thing out there. There's not going to be as many people getting vaccinated from the flu as we'd like there to be. So again, negative externalities are situations where the transaction produces external costs and the market's going to have more than we'd like there to be from a socially optimal standpoint. Positive externality is when the transaction produces external benefits and the market's going to create fewer of these transactions than we'd like it to from a socially optimal standpoint. So be able to draw a graph of a market before and after the effect of external costs are taken into account, and then be able to calculate dead weight loss. So again, if we're going to return to our plastic market that we've been looking at over the last couple of examples, so examples 2 and 3, right? What if we said that specifically there's a negative externality that comes from producing plastics, and that marginal external cost is $20 for each unit of plastic produced? You got to be able to calculate marginal social cost as that marginal private cost, which is just your supply curve, plus your marginal external cost, which is again given to you as $20 per unit. And then from there, you set the marginal social cost equal to the demand curve to solve for your socially optimal equilibrium, Q star and P star, right? And again, your new marginal social cost intercept, right? So that you can graph out these solutions. Then you plug that QM into your marginal social cost to finish finding the dimensions of that dead weight loss triangle and be able to calculate dead weight loss, which as of right now seems to be the issue that I think students are having the most trouble with based off of the questions I've been getting through email, as well as the scores on the thought-provoking question examples. So with that in mind, let's make sure that we can go through and do this. So before we get into the solutions, let's go back to our previous graph. Since we already calculated out the market before we take into account negative externalities, let's save some time and just add some negative externalities to that graph. Right. So again, I want you to recognize that your supply curve is also called your marginal private cost. And so if we want to figure out our marginal social costs, which we'll go ahead and do in green here, that's going to be equal to those marginal private costs plus your marginal external costs, which we give to you in example 4 here as $20 per unit. Right. So with that in mind, let's go ahead and calculate out that marginal social cost curve. So it's just our supply curve, which was 10 plus Q, plus our marginal external cost, which is 20, right? So that's going to be equal to 30 plus Q, right? So that's our marginal social cost curve. And again, if we want to set Q equal to 0 to figure out where that curve starts, right? We know that curve is going to start there at 30 units, right? So you're going to have a supply curve, a marginal social cost curve be exactly 20 units higher than your original supply curve at all points on that curve. So you could have a marginal social cost curve that looks something like this. Again, starting here at 30, instead of our original supply curve, which started at 10, again, we're going to be exactly 20 higher than that original supply curve. So if our marginal social cost curve starting at 30 makes sense because it's exactly 20 higher than 10. And so now it gives us a new equilibrium where it intersects with that old demand curve right here. And that's going to be our Q star and our P star, or our socially efficient price and quantity. So when we calculated out our original equilibrium, this is going to be our market equilibrium. This is where the market is actually operating. But again, in an ideal socially efficient world, given the fact that this market does produce some external costs every time it makes something, this is the market that we would rather be in. It's supposed to be in green there. Cool. All right. So again, we can calculate out this new market, this new socially efficient or socially optimal equilibrium, E star, by setting our marginal social cost curve now, instead of our original supply curve, equal to demand, right? So that's going to be 30 plus Q is equal to our demand curve, which is 110 minus Q, right? So that demand equation hasn't changed. So now we're going to add that Q's together here. So we're going to add that negative Q over to the other side. So we got 2Q equal to, and then we're going to subtract 30 over to the other side. So 110 minus 30 is equal to 80. That's going to give us a Q star equal to 40. So that's going to be the Q star here in this particular graph. Right. Now again, in order to figure out our P star, then we need to plug that Q star of 40 into either of these equations, the marginal social cost equation or the demand equation. Again, don't plug that Q star of 40 into your original supply curve because this equilibrium where we're calculating E star is not where we're intersecting with our original supply curve. It's where we're intersecting with our original marginal, with our new marginal social cost curve, right? So again, you can plug it into 30 plus that Q star, which is now 40, or you can plug it into our original demand curve, which is 110 minus 40. Again, either way, you should get the same result. So again, where a lot of students were having trouble with this on the thought-provoking assignment is that they were plugging their Q star into their original supply curve, right, and getting different numbers, right? Again, if you're calculating out that E star, you're not using your original supply curve. You're using your new marginal social cost curve. So make sure you plug that P star into plug that Q star into that equation to figure out your P star, and you should get the same number both ways. All right, so then we got P star here of 70, right? That's your new equilibrium price. And true to what we talked about, it looks like the market is overproducing here. It's producing 10 more units than would be considered ideal or socially efficient or optimal, right? In other words, when you account for the external cost that this market is providing, we should stop at E star and not go all the way out to EM. In other words, we should only be producing 40 units and not 50 units. Those last 10 units, the cost to everybody, society included, outweighs the benefit that is given to us by the demand curve. So we've got this extra section of transactions here where the costs outweigh the benefits when you actually include the external costs or the cost to everybody not included in that transaction. And so this extra unit here, or this extra amount of inefficiency, is what we call that dead weight loss. And if you were asked to calculate out the dead weight loss, which we'll go ahead and do in a different color here, we're going to do that in orange. Then dead weight loss is 1/2 base times height, or the area of this triangle. Now, in order to figure out the area of that triangle, we need to plug in our QM into our marginal social cost curve in order to figure out what the height of that triangle would be, right? So again, we're just looking at MSC at QM. And so that's going to be equal to 30 plus our QM of 50, and that's going to be equal to 80, right? So 80 is going to be that number there that's going to help us determine the height of the triangle. Or another way that you can think of it is that again, marginal social cost curve is going to be exactly 20 higher than our original supply curve. And so again, that difference between that 80 and that 60 should be 20, right? So it's a good way to check and make sure that you did it right. So that's going to be equal to 1/2, and the base of that triangle is going to be the difference in the number of transactions, which is 10 here. So 1/2 10 times the height of that triangle, which is 20. So that's going to be 1/2 of 200, or $100. That is the amount of dead weight loss. So it's going to be easier to see if you actually draw out these graphs. So if you get a question like this on the exam, I encourage you to draw out the graph to help you calculate things like these consumer surplus, producer surplus, and dead weight loss. It's just easier to see when you actually look at the areas that you are working with, right? So you are allowed a scratch piece of paper for the exam and something to write with, right? So you can go ahead and draw these graphs and calculate them out and then submit your answers online through iLearn, right? All right, but that's how you do that particular problem, right? And that's how you again, solve these externalities, or solve the socially efficient equilibrium when there is an externality present, and find out how much inefficiency is being created by the fact that we do have this negative externality that was unaccounted for with our original market equilibrium. All right. Know the potential solutions for solving negative externalities. Those include a Pigouvian tax. Remember, that is a tax that is exactly equal to the amount of external harm being created by producing something that has a negative externality associated with it. Now, again, remember, Pigou himself said that there's a problem with this, and that is it's hard to know exactly what that external harm is. It's hard to know exactly how much external damage is being caused by this pollution or secondhand smoke or whatever. And because you don't know exactly what the external harm is, you could set that Pigouvian tax too low, in which case we're still producing more than society wants, or you can now start setting it too high, which means that we're going to produce less than society wants. Right, so again, the idea is that you want to put a tax in the amount exactly equal to the marginal external cost, but it's hard to know what that amount is. Even if politicians were completely uncorruptible and didn't do things as a result of like doing favors for certain businesses in exchange for kickbacks or campaign contributions or whatever, even if politicians were as completely uncorruptible as we hope they would be, right, they still don't have the information to know exactly what that Pigouvian tax would be. Another potential solution is the coast theorem, right? That says that as long as these transaction costs are low and it's easy for parties to get together and bargain, then they're going to reach the socially efficient outcome privately, right? Just by paying whatever is the most efficient thing to do, right? So again, we talked about that rancher and farmer being next to each other and who should build the fence. Right, so again, it depends on what laws are in place, but either way, if it's more efficient to build a fence, the fence will get built. If it's more efficient to not build the fence, then the fence won't get built. Right, the laws just determine who pays who. Now, the problem with this potential solution is it's pretty difficult to engage in some of these transactions if there's a lot of people out there causing this negative externality. Right, so again, for this potential solution to exist, you have to have a situation where transaction costs are low and it's easy for parties to get together and negotiate. And that's not always the case. And then the third potential solution for overcoming a negative externality is you can internalize the cost through private property rights. If you give somebody, say, private property rights over the lake or the air that they are polluting, then now they are causing these costs to themselves in addition to everybody else, and they might be more inclined to get rid of them. Right, or to get rid of some of this production, right? So remember that whole tragedy of the commons situation, right? Sometimes when you have a communal resource, it tends to get overused or degraded, and a way to solve that is through private property rights. Those private property rights give you an incentive to produce in such a way that you are using your resources in a way that other people value. It gives you an incentive to care for and manage what you own, and it gives you an incentive to avoid that tragedy of the commons or conserve for the future, especially if you think that that resource is going to increase in value in the future. We talk about different ways that you can use private property rights to help maybe save endangered species or prevent this tragedy of the commons thing from occurring. Right, in the case of fishing in the ocean, right, you can combine total allowable catch with private property rights in terms of those individual tradable quotas. Right, we talked about how ownership over endangered species might help protect those endangered species, even if you legalize the selling of hunting licenses for those endangered species. You still have more in the future because now former poachers who now own these animals are going to work hard to make sure that there's animals in the future. And they don't want to kill these animals before they had a chance to reproduce and provide them with that future income stream. But you also don't necessarily have to sell hunting licenses to make money off these animals. We talked about how in Thailand you had an open area where these animals could roam, and then you just charge tourists to go and hike for these animals, and even charge tourists to help provide care for the animals, because the tourists like interacting with these animals so much that they will not only do things like feed them, bathe them, and make vitamin balls to help the elephants grow and prosper, but they'll actually pay for the pleasure of doing it. Right. So there's different ways that you can use private property rights to help maybe solve some of these negative externality issues. Also be able to solve or graph the effect of a positive externality and know the potential solutions for helping the market reach a socially optimal equilibrium. In the case of a positive externality, right, again, the solution there could be a Pigouvian subsidy. Right, remember that while taxes reduce our incentive to do stuff, subsidies increase our incentive to do stuff. Remember, taxes when the government charges you money for doing something. A subsidy is when the government gives you money for doing something. And so in the case of Pigouvian subsidy, you want a subsidy in the amount of the external benefit being created, right? So again, whatever the external benefit that's being created from having, say, somebody get vaccinated from the flu, you want to subsidize that activity in the exact amount of that external benefit, which once again is hard to know exactly what that is. All right, so it's hard to know exactly how much to make that subsidy. And we talked about subsidizing education as an example of this. But again, if you subsidize education too much, you drastically increase the cost of going to college. Again, if the greedy administrators at UC Riverside see that a bunch of students are getting checks from the government to go to school, and they'll start rubbing those greedy mitts together and knowing that they can raise those tuition prices and people will still pay it. So you might end up still paying more out of pocket to go to school than you otherwise would have. Right. So again, If you start subsidizing things too much, you could raise the price higher than what would be the socially efficient amount. And so that's something you need to worry about, again, is exactly how much the subsidy should be. And it's hard for government officials to know that answer. So let's go ahead and go through an example of positive externalities here. So let's say that we're talking about the market demand for electric cars is equal to 1800 minus 3Q. And the market supply for electric cars is equal to 300 plus 2Q. And let's say that this market has marginal external benefits equal to 500. Right, again, be able to calculate the marginal social benefit as the private marginal willingness to pay, which is represented by your demand curve, plus that marginal external benefit, which is given to you in this problem as $500. Be able to set that marginal social benefit curve equal to the supply curve to solve for your socially optimal equilibrium, quantity, and price, and also be able to get that new marginal social benefit intercept so that you can graph out these solutions. Again, plug that QM into your MSB to finish finding the dimensions of that dead weight loss triangle in order to calculate dead weight loss. So let's go through this example. We'll go ahead and start from scratch and calculate the market equilibrium. Never hurts to do that again, since you'll most likely have to do that on the test. And then we'll see how this market is affected by these external benefits. All right, so here's an example, the example that we just talked about. Again, if we want to go ahead and draw the graph, we got price and quantity here. Now again, you have a demand curve. You should know this is the demand curve here, the fact that it is negatively related to price, right? So if we're going to go ahead and figure out where this demand curve is going to set or start, then we're going to set that Q equal to 0, and from there we can solve for a price. So again, if Q is equal to 0, then our price is 1800. That's where this curve is going to start. So we'll say this is right here at 1,800. You have a downward sloping demand curve looking something like this. And again, we can figure out where that's going to hit that demand curve by setting P equal to 0. And solve for Q, right? So 1800 minus 3Q being equal to 0. If we move that Q over to the other side and divide by 3, we can see that Q is going to equal 600, right? That's where that's going to hit that x-axis. And it's important that you get in the habit of doing this. Even though we really haven't been using that number so far, we're going to start using it a lot in Chapter 5. That's why I'm kind of getting you set up to use it now, right? Now, again, we can go ahead and graph this supply equation as well. If we set Q equal to 0 for supply, then we know that this curve is going to start right here at 300. So again, our y-axis for the supply curve is going to start. It's going to be right here at 300. And that's going to be slightly flatter than our demand curve due to the fact that the magnitude of this slope is going to be a little bit lower than the magnitude of the slope for our demand curve. And again, you know that that 300 plus 2Q is a supply curve because Q and price are positively related there. All right. Okay, so let's go ahead and solve for this equilibrium here. Again, this is going to be our market equilibrium because we're going to solve for this before we take into account these positive externalities that are being created by these electric cars. So we're going to call this QM and PM. This is where our market is currently operating. And again, this demand curve here, this represents our private marginal willingness to pay. So again, our demand curve here is that marginal willingness to pay curve, right? Okay, so let's go ahead and solve for EM by setting supply equal to demand. So that's 300 plus 2Q is equal to 1800 minus 3Q. Now again, we need to go ahead and move all these Q's to one side. So we're going to add 3Q to the left side of that equation. That's going to give us 5Q. We're going to subtract 300 from both sides, which means subtracting it from that right side of the equation. That's going to be equal to 1500. So we got 5Q equal to 1500. That means that our QM here is going to be equal to 300. All right, so we can go ahead and plug that in right there. Now, if we want to solve for PM, again, we just plug that 300 into either of those two equations, or both of them if you want to be safe and check and make sure you did it right. So we got 1800 minus 3 times 300. That's our demand equation. If we plug it into the supply equation, that's 300 plus 2 times 300. Either way you do it, you should get the same answer, which is 900. So $900 is our very unrealistic price for electric cars in our electric car market. All right, again, I'm just trying to make the numbers easy enough for you all to calculate. All right, so with that in mind, right, we know what our equilibrium price and quantity are. Now we need to go ahead and take into the account that we have a marginal external benefit equal to $500 here, right? So again, this is given to you as part of the problem, right? So we need to go ahead and calculate our marginal social benefit curve. So remember, our marginal social benefit curve is equal to our private marginal willingness to pay plus our marginal external benefit. So in terms of the equations you've been given, that is that demand curve equation, so 1800 minus 3Q plus 500, that's going to be equal to 2,300 minus 3Q. All right, so with that in mind, we can go ahead and set Q equal to 0 first. We know that P is going to be equal to 2,300. So we know that this demand curve is going to start, again, exactly $500 higher, because that's the amount of the marginal external benefit, than our original demand curve. So we have a new demand curve looking something like this. And this is now called our marginal social benefit curve, because we've added in those marginal external benefits. All right. So where that intersects with the supply curve, that's going to be a socially optimal equilibrium of E star. That's going to give you Q star and our price P star. And by the way, if you want to find out where that marginal social benefit curve is going to hit that x-axis, right, then you just set P equal to 0 and solve for Q. So that's 2,300 divided by 3, which should come out to about 767 or so. Or at least 767 is the number once you round it. So we're going to plug that in right there. All right, so now we're going to go ahead and solve for our new socially efficient or socially optimal equilibrium, E star. And the way that we're going to do that is we're going to set our new marginal social benefit curve equal to our original supply curve. Right, so we got that marginal social benefit curve of 2,300 minus 3Q. And we're going to set that equal to that 300 plus 2Q, which is our original supply curve equation. And once again, we're going to add our Q's to one side, and then we're going to subtract 300 from both sides here. This is going to be equal to 2,000 is equal to 5Q, right? And then we can go ahead and solve that our Q star is equal to 400. Right, now again, if we want to solve for P star, then we just plug that 400 into either our marginal social benefit equation or our original supply equation. Right, again, don't plug it into the original demand equation because we're no longer using that original demand curve to get this new equilibrium. Right, so again, we're plugging it into our marginal social benefit equation, and that is 2,300 minus 3 times 400, and that's going to be equal to 1100, right? Or you can plug it into your original supply equation. That is 300 plus 2 times 400, which is also equal to 1100. Right, so 1100 is our P star, right? And again, 400 is our Q star. So true to what theory would suggest, our socially optimal equilibrium is going to yield a production that is higher than what the market would otherwise produce. So again, if left up to its own devices, the actual production of this market will be less than what we like it to be from a socially efficient standpoint. And again, the price is lower than we'd like it to be from a socially efficient standpoint. So again, the issue is that we have 100 extra transactions here where the benefits would outweigh the costs if you take into account the fact that this activity is providing benefits to other individuals. In other words, the market stops at EM, but we would love the market to continue all the way to E star. In other words, we are only producing 300 units, but given that the marginal social benefit curve outweighs the supply curve, or again, the benefits to society outweigh those private costs, we love the market to continue all the way until we're producing 400 units. So the fact that we are not producing these 100 units means that we are not producing enough from the socially optimal standpoint, and therefore we are creating again some dead weight loss, which we'll go ahead and again calculate here in orange. Right, so it's represented by the area of that triangle there, right? So again, there is 100 fewer units out there than we like there to be. In order to figure out the height of this particular triangle, then again, you can just remember that our new marginal social benefit curve is exactly 500 higher than our original demand curve, right? In other words, you add that 500 to the PM, or the original price that you calculated, and you should get 1400. Right. Now, if you can't remember to do that, then again, you just look at your marginal social benefit curve at that QM is equal to 300. Now we're just going to plug QM into our marginal social benefit curve. So it's 2,300 minus 3 times that QM of 300. That's 2,300 minus 900, which is indeed 1,400. All right, so now we have the dimensions of our triangle. The height of that triangle is 500, and the base of that triangle is 100, right? So again, our dead weight loss is equal to 1/2 base times height. So that's 1/2 of 100 times 500, or 1/2 of 50,000 gives us 25,000. So that is your dead weight loss, and that's how to calculate it. So in the case of a positive externality, again, the trick is to add the marginal external benefit to your demand curve. In the case of a negative externality, the trick is to add the marginal external cost to your supply curve. Other than that, it shouldn't be too hard to calculate. I think you all could do it if given the opportunity to do it on the exam. All right. Now, also in Chapter 4, make sure you know the definition of a public good. Remember, to be considered a public good, it has to have these two key characteristics, none of which are whether or not the government provides it. So remember, the government provides both public goods and private goods. The fact that the government provides it does not in and of itself make it a public good. To be considered a public good, it must be non-rival in consumption. That means that multiple people can consume this at the same time. One person's consumption doesn't interfere with somebody else's consumption. And it has to have both of these, and it has to be non-excludable. And that means that it is impossible, or at least incredibly costly, to exclude any non-paying customers from enjoying this good. So we gave some examples in class, like an outdoor fireworks show, right? Again, it's non-rival in consumption in that you can look up at the fireworks, I can look up at the fireworks. We can both enjoy the fireworks at the same time. You seeing it doesn't interfere with me seeing it. right? It's also non-excludable in that even if I didn't contribute to or pay for that fireworks show, I can still enjoy the beauty of it just by looking up. You can't really stop me from looking at the fireworks once it's out there lighting up the sky. Again, you could try to do something like stab out the eyes of all the non-paying consumers of this fireworks show, but if you did that, that's what we mean by incredibly costly, right? So again, it has both those key characteristics. That's what makes it a public good. National defense is another example of it, right? You can enjoy the military's protection or protection at the same time that I can, right? So we can both enjoy that military protection at the same time. You enjoying it doesn't interfere with me enjoying it. And again, you can't really exclude somebody from enjoying that protection of national defense. Like you can't say protect the entire country except for maybe the state of Idaho, who chose not to pay taxes towards national defense that year, right? You can't allow Idaho to be taken over while still protecting the rest of the nation. All right, so again, non-rival consumption and non-excludable. Know the problem that characteristics of public goods poses for the market. So in the case of public goods, the market might produce too few because of this issue called these groups of people known as free riders who are going to try to enjoy the benefit of the good without paying for it. The fact that it is non-rival consumption and non-excludable means that these free riders might be able to enjoy this good even if they don't contribute to it. And because of that, they're going to be willing to underrepresent how much they care about this good because they think, I'll let somebody else pay for it, well, I'll still enjoy it. And as a result, you have too few of these things out there, or less out there than the market would prefer. And then with that in mind, right, the fact that these public goods tend to be undersupplied due to the presence of free riders, know the potential solutions for this. And that is, one, you could have private agreements, for example, like a homeowners association, where private individuals get together and agree to pay for this as a group. And again, this is easy to do if transaction costs are low and bargaining is easy. This is kind of similar to that whole coast theorem idea. You could have direct intervention. So in other words, if we can't get people to get together and agree, the government just says, all right, this is how much national defense we think there should be. If you won't agree to pay for it on your own, then we're just going to charge people in taxes, make you pay for it, and provide the level that we think is efficient, whether that level is what the people want or not. And then the third one is that private markets can provide a public good by tying it to a private good whenever possible. So, for example, we talked about how radio broadcasts are a public good, but we tie it to advertising dollars in order to make sure that there's enough radio broadcasts out there. Lighthouses are another example of a public good, right? They're non-rival consumption and non-excludable. So how do we make sure that there are lighthouses out there and that the lights are always working? Well, if you use that lighthouse to guide your boat into the dock, you have to pay a docking fee, and that docking fee is used to contribute to the upkeep and maintenance of that lighthouse. So again, by tying something that is excludable or is rival in consumption, like space at a dock or advertising space, to a public good, then you can make sure that enough of that public good is provided. So we went through a quick example in class on how to figure out exactly what the market would provide versus what would be provided by a socially optimal standpoint. So let's go through another example to make sure you can do one on the exam. So it says the following portions of the demand curve of these three individuals for the water quality in a small pond are given here. The water quality is expressed in terms of the parts per million of dissolved oxygen. So water quality improves with higher dissolved oxygen levels. The demand curve shows you the marginal willingness to pay of each individual for these different levels of dissolved oxygen. Calculate the aggregate marginal willingness to pay for all three individuals. If the actual marginal cost of increasing this dissolved oxygen is $10, what is the socially efficient level of dissolved oxygen in the lake, assuming these three people are the only ones involved? And then what is the market level of dissolved oxygen in the lake? So first things first, if you're calculating out the aggregate marginal willingness to pay, then you just add up the marginal willingness to pay for all three individuals, right? So in this first case, right, the marginal willingness to pay is 10 plus 10 plus 12, which is 32. That's how much the three together value having this much dissolved oxygen in the lake, right? Now, if we want more dissolved oxygen in the lake, right, then we are going to need to add up these marginal willingness to pay across these three individuals at 1. So that's 6 plus 8, which is 14, plus 10, which is 24. So again, if we're going to add up aggregate marginal willingness to pay for 2 units of dissolved oxygen, it's 4 plus 6, which is 10, plus 8, which is 18. I think we get how to do this. So the aggregate marginal willingness to pay for 3 units of dissolved oxygen is 10. For 4 units is 6. For 5 units is 2. For 6 units is 0. And it tells you in the problem that the marginal cost of increasing dissolved oxygen is exactly equal to $10. So again, the socially efficient amount is where the aggregate marginal willingness to pay is equal to the marginal cost. That's like saying the marginal benefit to the community is equal to the marginal cost to the community, right? And so that happens right here, where marginal aggregate willingness to pay is 10. So the socially efficient level of dissolved oxygen that we should see in the water is 3 units. So again, this is what we call the socially efficient amount, or socially optimal level. But the question is, will we see 3 units of DO in the water if we ask each of these individuals or individual households how much they're willing to pay, right? So, like, will we see 0 units? Well, person C is going to vote yes in terms of getting that 0 unit level because 12 is greater than the cost of 10 to them, right? Person A and person B will also vote yes, right? Because again, the $10 of cost to them is equal to the equal to their marginal willingness to pay. Right now, if we're asking, are we going to have 1 unit of DO in the water? Right. Well, again, person 1 is willing to pay for it. Right. In other words, their marginal willingness to pay of $10 is equal to the marginal cost of $10, so they'll vote yes. Person B will say, no, I'm not willing to pay that. I'm only value it at $8 and it costs me 10, right? Person A here is also going to say no, right? But as long as one person is willing to provide it, then it'll still be provided for everybody. It's just now the case that person or households A and B, right, they're going to free ride off of the person or household C's willingness to pay for it. So that's definitely going to happen, right? Now, when it comes to the case of if they're going to be willing to provide 2 units of dissolved oxygen in the water, right? Person C here is going to say, no, I'm sick and tired of people free riding off of me, right? It's only worth 8 to me. The cost is 10. I'm not going to be willing to do it by myself. Person B and person A are not going to be willing to do it by themselves either, so it's not going to get done. And the same thing is true for the 3rd unit of dissolved oxygen, right? So what's going to be the actual level? The actual level is going to be right here at 1, which is unfortunate to everybody in society, given that we want 3 as a group anyway. So once again, this is going to be underprovided because of people trying to free ride off of others' willingness to pay. So again, the actual level of dissolved oxygen is going to be 1, although the socially efficient level would have been 3. Right? So again, there's going to be fewer units out there than the market would like because, again, free riders are trying to enjoy the benefit of this without necessarily be willing to pay for it. All right. And so if you get that, then that is the end of chapter 4, and that is all that's going to be covered on your exam. So if you can do those kinds of math problems, then you should be okay as far as the math and graphs are concerned for the test. Again, make sure you understand the concepts that we focused on in chapters 1 and 2. And as always, just let me know if you have any questions. Just feel free to shoot me an email or come see me during those Zoom office hours. I hope this review session was helpful. Again, if you need anything at all, just feel free to let me know. Other than that, there is a review, not only these review session slides and video posted for you, but there's also a study guide posted for you, all of which to help you get ready for that exam coming up. So happy studying, good luck, and once again, just let me know if there's anything I can do for you as you're getting ready for the test. Take care.